nothing happened. Only the morphology changed. The chemical is the same. So what do we call it? Isomerization. What is the enzyme? Isomerase. Okay, I don't talk the full name. Okay, it's a biochemistry class. You guys, Kim Barnes or Dr. Lam will talk about those. Okay. Or Dr. Krause, Marie Krause will talk about that. I don't talk about those. Isomerase. This is an isomerization. Okay, when you see here, do you feeling about it's like a twin in your family? You have a younger sister, 5 years old. You have a sister, 4.5 years old. One has an apple, another one don't have an apple. I need to give an apple, is that right? To keep them happy. So I need to add one more. That's why we comes out with the same thing right here. Let's draw here. CH2OP. This is OH. Then you go OH, H, OH, back H, CHOP. What is this? Fructose 1,6-biphosphate. Each have the apple, okay, balanced. Now where is this? Where the apple comes from? Where the phosphates comes from? ATP hydrolyzed from ADP and phosphates. Okay. At this stage, we are talking about right here. This is called the investment area. Lose 2 ATPs, you use 2 ATPs, pay the 2 ATP currency. Okay? Now, we're going to go back to chemical again. Once you have this fructose 1,6-biphosphate, what's going to happen? Look at this structure. This is the same thing for our animals. You have a muscle, you have a joint, you have a nerve, you have this structure, you can do relaxing contraction. When you see this structure here, everybody get an apple. What are you going to do then? Everybody get some money. Think about your family. Your sister and your brother, both elder sister, young sister, both get $1 million. What are they going to do? Are they really going to work together? No. They are trying to separate. They each do their own investment. Somebody using $1 million buy a house, sometimes maybe go to a good university. Is that right? When you see this structure, it's not really stable. It's ready for you separate. Oh, of course it's not exactly, okay? Very similar, you're going to separate it. Therefore, it moves on to 3-carbon phase. This is 6-carbon phase. Okay, what are the 3-carbon phase for? What is this one called? What is this called? Aldehyde, is that right? This is aldehyde. If you want to draw this very like this. Aldehyde. Phosphate right there. Well, then what is called? Glyceroldehyde 3-phosphate. Okay. When you go here, what enzyme we need? Is that glyceroldehyde kinase or something? Is that right? Then when go here, what do we need? Is aldose. Okay, we skip those. Those are not much meaning. We don't talk about the enzyme too much. Glyceroldehyde 3-phosphates. Don't forget, there is a transition stuff. This is sometimes mentioned in chemistry class, sometimes it doesn't mention. It's a transition stuff. Dihydroxyacetophosphates. What is dihydroxy? What is hydroxy? Is this hydroxy? What is acetone? Is this ketone? What is phosphates? Right here. So you need to know the structure. Otherwise, you just remember the name dihydroxyacetone phosphate and glycerol dihydroxy phosphate. You only know the name. That's not really with the way to study. Okay, then you forgot about in 5 minutes submit the exam paper. Then next time you learn again. Then you forgot again. Then you learn again. Then one day you don't study, then you forget everything. Okay, so that's what we have. Glycerol dihydroxy phosphates. Next one, what we have. These are easy compared to here. Okay, that's three chemical. What we have? COOP. Then we go CHOH, CH2OP. What is this one? 1,3-biphosphoglyrate. Here is something we want to mention. How this comes? You have a glycerol that has 3-phosphate. How the hell you come from 1,3-biphosphoglycerate? Where it comes? Do you remember? This is coming from the inclusion of a bacteria. Remember this guy? What is this? Corynebacterial diphtheria, is that right? Klapsik. What is this called? Inclusion. And I said the inclusion storage what? Phosphates. This is where they come from. So this tells you a bacteria has to survive. You must have the inclusion to storage phosphates. If you don't have it, you can't go through this. You usually start from here. That's some of the inhibition. They take out the inclusion. They take out the structure, which is can storage phosphates. That's what it is. Okay? Now, at this moment, what is going to happen? Is these are gone? Is that right? Or still there? NADH, NAD become NADH2. What's the enzyme for this guy? Dehydrogenase. Is that correct? Yeah, let's go back. I didn't even read it. I just based on my understanding. Okay, it's still there. I thought it should gone. It's not gone yet. Okay, it's still there. Okay? 1,3-biphosphoglycerate. Then what we got? 3-phosphoglycerate. Okay. On the top. It's not gone yet because it's stable. It's more stable. The energy is not enough. You can see the delta G is enough. What is this one? 3-phosphoglycerate. Then where is that one goes? ADP. Add the phosphates becomes ATP. Okay, that what happened there. So 3-phosphoglycerate. Then what's the next one going to happen? 2-phosphoglycerate. What going to be the 2-phosphoglycerate? It's going to move up a little bit. Is that right? Then what about here? CH2OH. Is that right? Look at this, CH2OH. Yeah, CH2OH. 2-phosphoglycerate. Let me take a look. Okay, almost, just missed one. Okay, the last one. Then you go here. What is the enzyme of this one, by the way? Mutase. Okay, when you go here, what's going to happen? Phosphoenolpyruvate. That's analase. LASE. That's analase. So what happened? COH, let me see it. That's COOH. OP, and this is becomes CH2. That's phosphoenolpyruvate. Okay, goes down last one. This has to go. Okay. Then become what? Pyruvate. What is this enzyme for? Kinase, is the right pyruvate kinase. What is this P go? ADP with this phosphates becomes ATP. Okay. So how many ATP generate? One right here. 1,3-biphosphoglycerate becomes 3-phosphoglycerate. Another one is right here. Phosphoenolpyruvate becomes pyruvate. So one right here and one right here. So 2 ATPs generate. 2 branches, is that right? So equals how many? 4 ATPs. Use the 2. Add up 4 ATPs. Equals what? 2 ATPs. Okay, here is the key. This 2 ATPs is where we come out from. Glycolysis is a isolated cycle, is in the absence of oxygen. If it's in aerobic respiration, what's the difference? Then we're going to go back to see here. This comes out. During the aerobic respiration, chemosmosis will be happening. This will be related to the electron transport chain. So how many ATP generated? 3 ATPs. Is that right? Some people say 2.5 ATPs, that's okay. I'll just use the older one. Okay, easy to calculate, 3 ATPs. So how many generated here? So instead of you have 10 ATPs. So if you add 10 ATPs, this equals 8 ATPs. Therefore, if you really want to say glycolysis, 2 ATPs, this is what you learned in your class. This is coupled with fermentation. In the absence of oxygen, no oxygen, okay? And 8 ATPs will generate, coupled with aerobic respiration. This is a conclusion. Okay, this is a way you're going to learn. So the key thing here, I didn't even read it. I didn't even prepare. That's why I'm late. I got doing the other things in the morning. I just, based on my understanding of the structure, I missed a little bit right here. So this is, I'm showing you how to learn. This is the first time I'm drawing so slow. Go here. I usually, in my previous teaching, I just spend 10 minutes and wrote. Then people say, why you remember it? Because I just read it. But this time I didn't read it. I based on my understanding about chemicals. If you understand the chemicals, I missed a little bit here. Then I thought about the delta G, is that right? Because you learn in your other classes, it's not enough to take those out. So you may miss a little bit here. So what this means, if you know the chemical structure, this, you should get an extra points. And you may miss one or two, like what I forgot about here. Maybe one or two here, that's all. And you even know the word. You just forgot about structure a little bit, missing like 1 point just. How many you can get? 1, 2, 3, 4, goes here. 5, you can write that's okay. 6, 7, 8, 9, 10, 11. I didn't get these two, so I get 10 points too. If you know the structure, is that right? So that's why the story I want to show you a little bit slow is there is a way to learn these things. And I hope everybody, at least, even you're not very good at biochemistry for memorization, at least you know these words, is that right? And at least you know what is glucose 6-phosphate. If you forgot about this, this is okay. This is a little bit tricky here. Because this is OH, this is OH, is that right? But these should be easy. So you go here, the pyruvates you should know, is that right? If you forgot about the others, it's okay. These are a little bit tricky. There's a phosphate, there's the HOH, there's again, there's a carboxy group, there's a ketone there, there's an aldehyde there. Is that right? So, but you don't have to be really understanding, memorizing anything. You still can get at least 6 points or 7 points each. So that's why I'm going to show you how you're going to really learn about that. Okay? So this is the way we finish talking about fermentation and glycolysis. Then we'll continue to talk about TCA cycle on Thursday. Okay?